What is function prototype? Give syntax of the function prototype and why is it necessary. So declaration of user-defined functions, whichever we are using in a program, is known as function declaration or function prototype. So you should understand the difference between user-defined functions and built-in functions. Built-in functions are written by programmers, while user-defined functions are those which the programmer, while writing the program, is defining in order to implement some of the functionalities. So user-defined functions are those functions, suppose in our example of linear search, we are making, when we are writing the program for linear search, we are making a function called lin search, and so that function, when it is being called from main, it will be executing the linear search and it will be returning the position of the element in the array. So, this user-defined function called insearch is defined by the programmer, right? So this type of functions which are defined and declared and called by a user, for that the particular declaration which we are giving before the main is known as function prototype. So declaration of the user-defined function will inform the compiler, and also the user will get to know what is the name of the function, what are the arguments which we have to pass for this function, and what will be the return value or what will be the return data type, and how to call the function. So these are the details which we are passing on to the compiler as well as any other user whoever is trying to use this program. So a function prototype is also known as function declaration, and the syntax is the return data type followed by the function name, and in bracket we have to pass the parameter list. So here in this example, suppose max is the function name, return data type will be integer, and the arguments passed will be two integer values num1 and num2. What are the advantages of using recursive functions? So what are recursive functions? Recursive function is a function which is defined in terms of itself. So in recursive function, we will be calling the function which is written in terms of itself. So there is a repeated call of the same function again and again. So recursive function is a function which contains a call to itself. So in case of such problems which can be solved only by the repeated call of a particular function, that can be which can be reducing the total length of the program, can be implemented using the recursive function. So some functions will be recursively, some functions will be calling one function from another function. Suppose from main it will be calling another function, and from that function we will be calling another function. But in case of recursive function, from main it will be once calling this recursive function, and thereafter the recursive function will be repeatedly calling the same function itself. So the problem with recursive function is like whenever a particular function has to be fully completed, it has to call the inner function. So it will be repeatedly calling the same function. At the end there will be an exit condition. When that is satisfied, it will stop recursively calling the function. So thereafter the return value will be backtracked to the initial call which was made from main. So this will help in reducing the complexity of the problem, and programs will become smaller in length, and it can have any number of nesting levels. So what are the disadvantages? The problem is, like, if we are keeping on making the recursive call, there is no end in we will not get an immediate solution for that particular recursive call. So when the end, as I told before, when the recursive function will be stopping the recursive call only when an exit condition is satisfied. So when that particular exit condition is given, the value of that last call will be substituted in the previous call. So all these incomplete calls will have to be stored in an extra storage space until the backtrack value reaches that. So this will be recurring in extra storage space, and the recursive calls and the variables are stored on the stack. So in order to keep these recursive calls which are incomplete and waiting for the final value of the final exit condition to be backtracked, has to be kept in a storage space. If the exit condition is not specified in the recursive function, the program will execute out of memory, and the recursive function is not efficient in execution speed and time. As we know that the call will be completed and the effect will be there. Suppose we are doing the GCD, all the recursive functions will be recursively called, and at the end the backtracking also has to be done in order to complete or to get a solution for GCD. So this will increase the speed time, as we have to call once and then backtrack. So twice the time taken will be there. So it will increase the speed of the time taken for execution of the particular or finding a solution for a particular problem, and it will take more time than the iterative model. So next question is, write short notes on formal and actual arguments. The values passed to the function by the calling function are called arguments. So we know that when we call a function, when we declare also, we will have to inform the compiler that what is the name of the function and what are the arguments passed to the function, what is the return value. So the values which are passed to the function by the calling function are called arguments. So we know that when a function is called, a function will be called either from the main or any other function, or so the function when it is called, suppose in our example of lab program, linear search program, we had called lin search, the name of the function, from the main. So so when we are calling the function, whatever arguments we are passing, those arguments are known as actual argument. The parameters passed to the function call are called the actual arguments or parameters. So the actual arguments or parameters, the parameters are the different are another name for the arguments. Parameters which are given in the function definition. So when we call a particular call function, it will be reaching the function definition, and those parameters which are mentioned in the function definition are known as formal parameters. So from the actual parameters which are there in the function call, the value of the arguments will be copied into the formal arguments. So from the actual, we will be copying the value in the same order for the arguments which are mentioned in the function definition. So the number of actual arguments and formal arguments should be matching in number and data type and also in order. The value of the actual arguments are assigned to the formal argument. So it will be like a one-to-one assignment from the actual to the formal. How to declare and initialize a two-dimensional array? So we know that two-dimensional array or matrix, we can tell a two-dimensional array, it's or a matrix as a table of values, right? It is a collection of values of the same type and same name arranged in two dimension. That is one, you can imagine it as a x and y dimension. So there are two dimensions, and it has a finite number of rows and finite number of columns. So we have to mention the size of the or the number of rows and columns of a particular two-dimensional array. The declaration of the two-dimensional array is done as data type followed by the array name and then followed by the row size and column size. Row size and column size will be giving you the total number of rows and total number of columns. So in this example, integer A55 means the data type is a integer, and the size of array is 5. Row size is 5 and column size is 5. Arrays are derived from the primary data types integer, float or character. And the row size and the column size should be a constant and is placed in square bracket. The first index indicate the row size and the second column within the indicate the column size within each row. So initialization of two-dimensional array can be done either by the direct assignment for all the values in the matrix, or you can follow the initialization as row by row. So if you are directly assigning all the values, suppose a matrix of size 2 by 3, that is 2 rows and 3 columns. So we can directly give all the values within a curly bracket. So you know that as the matrix is of size row size 2 and 3 means the total number of elements which will be taken by this matrix will be 2 into 3, that is 6. So we have to pass all the 6 elements within the curly bracket separated by commas, ending with a semicolon. So here there can be 6 elements. We have to pass 6 elements, 1 2 3 4 5 6. So these 6 elements will be placed as the first 3 elements will be in the first row, and the second and the following elements, the 4 5 6 elements will be in the second row. So this will make up the matrix of size 2 rows and 3 columns. So this is for the direct assignment. If you are going for a declaration followed by initialization, so in this example it was like here we have the declaration of the array followed by the initialization. If you are taking it in 2 steps, that is first initialization or declaration, first declaration and then initialization, then it will be like each element which can be each position in the matrix which can be accessed by the index number matrix 0 0 equal to 1, and then matrix 1 2 or matrix 0 0 1, matrix 0 2. Directly we can assign each value for each index position. So this is how to declare and initialize a two-dimensional array. What is an array and how to access the array elements? An array, as we all know, is a derived data type. Arrays are derived from the primary data type. It can be either integer or float or character array. So it is nothing but a collection of data types which is referred by a single name. When an array is used to represent, it can be used to represent a list of numbers or list of names. When we declare an integer array, we are referring to a list of numbers. When we are declaring a character array, it can store more than one character. Or if you are declaring a character array of a 2 dimension, we will be able to store a list of names. Individual array elements can be identified by the subscript or the index number given in bracket. So when we declare an array, we will be mentioning the total size of the array, and if you are going to access the elements, you will be using the index number. So in order to assign value to the third as a third element in the array, we will be having on the left hand side we will be having the array, and so the third element, as you know, as the index number is starting from 0, the third element is referred as index number 2. So 23, the value 23 as given in the example, the value 23 will be assigned to the third array element at index number 2. And now to access the array element, and in order to get the value from the array, we and to assign to a variable, supposing a is an integer variable, array element can be accessed. Suppose the value 23 which is assigned to the as the third array element in the array called number can be accessed with the index number 2 in square bracket, and the value is if you want to store it in another variable called a, you can assign into a variable called a, which is on the left hand side. The value of the second element from the array is assigned to the variable called a. Now, what happens when an array with a specified size is assigned with the values fewer than the specified size, and second case is with values more than the specified size? So what happened in these two cases? So the first one, like when with values fewer than the specified size, as we all know, in order to declare an array, you will be giving the data type. Suppose it is an integer array, you will be declaring using a data type, and then we will mention the array variable name followed by the size in bracket. Suppose I gave the size as 5 during declaration, and then in the first case, when we are assigning values fewer than the specified size, suppose if it is an integer array, and if we are trying to assign values fewer than, suppose as the size is 5, if I am assigning only 3 elements into the array called a, what will happen? So here we can see that if it is an integer array, the remaining empty positions in the array after the third. So the first element will be at index number 0, second element will be at index number 1, and the third element will be at index number 2. And you know that as a size we had given as 5, so the remaining 2 locations, it will be empty. So when the numbers are assigned, there will be, as we had assigned only 3 numbers, in these empty locations we will be having, automatically it will be assigned 0. So if it is an integer array and if it is a character array, after filling the characters for the 3 characters, the remaining positions, it will be automatically updated by a null character. So this is the first part, that is if the size of the array is specified and if we are providing only and if it is initialized only with the with a lesser number of elements, what will happen? The remaining elements will be taken as 0. So automatically it will be taken as 0. If it is a character array, it will be taken as null character. Got it. So now the second case, with values more than the specified size. Suppose I declare the size as 5, and if I am trying to assign 6 values, what will happen? In such a case, if more values are we are assigning more than the size of the array, then it will the compiler will produce an error. Now, what are the classifications of array? We have already studied that arrays can be either one-dimensional array, or it can be two-dimension, or that it can be multi-dimension. One dimension means there is only one subscript and it is referred by only one variable name, right? And only one index number will be there, which will be given as a subscript, right, within the square bracket. Declaration also will be mentioning only one square bracket, and when we are accessing also we will be referring only by the only one subscript. Now for a two-dimension array, for a two-dimension array, there are 2 dimensions. That means 2 subscript. That is one subscript for the number of rows, and the other subscript will be indicating the number of columns. So a two-dimensional array will be having, as we know, it will be in the form of a table or a matrix. And when we are declaring a two-dimensional array, we have to mention the data type, the variable name, followed by the row size and column size. So when we are accessing or assigning the values for a two-dimensional array, we have to indicate both the row and the column subscript. Now, what is multi-dimensional array? Multi-dimensional arrays are those arrays with more than one subscript. So here you can see that a two-dimensional array is also falling under multi-dimensional array. So in for example, so it can be referred as, for a three-dimensional array, we can as obviously it will be having 3 subscripts, right, and so on. So if it is a 4-dimensional array, it will have 4 subscript. So here the syntax for the declaration will be the data type followed by the array variable name followed by the dimension or the sizes of 3 dimensions. So here we are not referring to as the row size and column size. We are just indicating the subscript, 3 subscript, so which will indicate the size in 3 dimension. So in order to declare also, we will be giving the data type followed by the variable name followed by the 3 sizes of the 3 dimensions. How are the elements in an array stored in memory? So as we had imagined for a single dimension array, all the elements will be continuously placed in the array. But what will be the case of a multi-dimensional array that is having more than one subscript, 2-dimension as well as more than one dimension, like 3-dimension and 4-dimension. So elements of the array are stored in contiguously increasing memory locations in a single list, and whether it is a 1-dimensional or 2-dimensional array, it will be kept in the memory with an continuously or contiguously increasing memory locations, or we can tell it as adjacent memory locations as in the form of a single list. A 2-dimensional array is stored row-wise starting from the first row and ending with the last row again. So this, in the case of a single dimension, we can as we all imagine, it will be placed continuously in a single row. But in the case of a two dimension also, we will be as contrary to our imagination, it is not placed in memory in the form of a table or a matrix. It is placed row wise. So the first row of the matrix will be, or the two dimensional array will be stored in a row, followed by the second row. So the second row which is placed, which is imagined to be placed down, will be kept after the first row continuously, and then it is followed by the third row. And so if it is the three-dimensional array, what we imagine to be placed in three rows in memory, it is not actually placed in three rows. Actually, the first row will be followed by the second row, and it is followed by the third row. So this will be it will be like a row wise arrangement in memory. First row followed by the second row, and then ending with the last row. It is not possible to store a 2D array in rows and columns, and memory in computer is organized linearly. So whatever be the number of dimension, it is not placed in rows and columns in memory. It is organized linearly. A two-dimensional array can be considered as a collection of one-dimensional array. This point should be there. It is a collection of one-dimensional array that are placed one after the other. So it is opposite to what we imagine. It is not placed in memory in the form of a matrix. It is a collection of one-dimensional array. So if it is a two-dimensional array, or you can write it for any of the dimension, multi-dimensional array also. It is like it is a collection of one-dimensional array. What is a string and what is the length of a string computer? So you know, a string is made up of a sequence of characters. So here the string computer is again made up of a sequence of characters C, O, M, P, U, T, E, R. So C does not have a string data type. That is a specialty of a C language, that it doesn't have any string data type. If you want to store a string is an array of characters. So if you want to store a string, you have to declare a character array, and that array variable alone, if you are indicating, that stores the address of the first index position. So if you want to access the first character, you have to index the array variable. So with the index number 0. The string in C programming is a one-dimensional array of characters which is terminated by a null character. If you are entering character by character or as a character constant, then you have to end or terminate the array of characters using a null character to indicate the end of the string. But if you are initializing the character array as a string, then automatically a null character will be appended at the end. Now the second part of the question, which is what is the length of the string computer? So the string length is a function which is used to count and return the number of characters in a string. So the string length of the string computer, when it is passed as an argument, either as a variable which is having the computer, or directly if you are passing, then it will be counting, and it will return the length as 8. So for the string length of the computer is 8. The counting ends at the end of the first null character. You can either use string length function, or you can write a C program to count each character by character of a character array until it encounters a null character. Now, explain different string library functions used in C, or explain the string operations. So there are different string operations, and these string operations can be done using string functions which are available in the C library. So the string manipulations can be like finding the length of the string, the string copy, string concatenation, uppercase to convert the lowercase characters to uppercase, or to vice versa, or from the lower to the upper or upper to the lower. And there are many such operations which we can perform on string. These operations can be done either using writing C programs, or you can directly use the string library functions which are available in the header file string.h. So it will be used to carry out the various string manipulations or the string operation. The first function which is used is string length function, which counts and returns the number of characters in a string, and it is used to calculate the length of the string. So it will take only one argument, that is the string name, and the string length returns an integer value, which will be the total count of the characters until the null character. As we know, each string will be ending with a or terminated with a null character. It will be counting the number of characters. So here in this example, we have initialized the string character array of size 10 with the string computer. So it will be returning. So as we know, even though the size of the array is 10, the length of or number of characters which are present in the string computer will be 8. So it will be returning 8 as a length of the string computer. The array size is declared as 10, but the remaining 2 character position. So after R, it will be terminated with a null character, and then the one more empty character position will be also initialized by a null character. So it will be returning the number of characters. That means in computer there are 8 characters before the null character, so it will be returning 8 as the length of the string. The string copy second function, which takes 2 arguments, which are both character array, and both will be the arguments will be the character array. So the intention of using string copy is to copy the content of the second string argument to the first string. So suppose we are giving string copy string 1 comma string 2, then the content of string 2 will be copied into, or it will overwrite the content of string 1. Suppose here I have initialized character array str1 and str2, and I have initialized string 2 as with the string. This is C programming. So if you perform string copy of str1 and str2, the content of str2 will be copied to str1. Now, the third function, a string function, will be string cat, which is used to concatenate or to join 2 strings. This also takes 2 arguments. The 2 strings will be joined and stored in the first string, which is specified as an argument. Suppose we are using string cat with the 2 arguments str1 and str2, and suppose here in this example str1 is initialized to this is, and str2 is initialized to C programming using the string concatenation function, that is strcat. It's not a con, it is strcat string cat with the 2 arguments str1 and str2. The content of str2 will be appended, or it will be concatenated with the content of string 1. So string 1 was having this is, and string 2 C programming will be now appended into str1, and if you try to print str1, the content will be this is C programming. String compare. String compare function will be comparing 2 strings, and it will return 0 if the 2 strings are equal. So the 2 arguments again should be 2 character array variables which is storing 2 strings to compare. So here in this case, as we already know, there are 2 string compare function. One is strcmp and the other one is strcmpi. So when we are using strcmpi, it will be case insensitive, but in this case, as it is case sensitive, if you give str1 as ABC and str2 as capital ABC, it will be returning the strings are not equal. So if it returns 0, that means the strings are equal. So in this case, here the string compare of str1 and str2 will not be returning 0 because ABC is the first string and DEF is a second string. So it may be either a positive or negative value depending upon the ASCII value of the characters. So even if we give capital ABC and small ABC also for str1 and str2, it will be returning the strings are not equal. So it will not be returning 0. Now moving on to the next question. The string library functions which are used in C. Explain all string operations. You can summarize with this same which we have explained in the previous. Suppose they are asking only for the six functions, you can elaborate on that. And suppose if they are asking to write all the string functions, you can just brief out all this. So if you want to go before exam, if you want to just summarize and see, you can have the slide string length, str lwr to convert from the convert to lowercase, and strupr for converting into uppercase, string cat for appending or concatenating to characters. Now there are certain other functions which I have not taken. That is also for strncat. That is only the only difference between string cat and string ncat is it will be appending the first 10 characters. That if you are skipping also, the remaining you can write. String copy, again used for copying a string to another. Then string compare to compare two strings, and string compare I to compare two strings regardless without regarding, that is case insensitive. And again stricmp to compare two strings without regard to the case. It can be either I can be at the end or in between strcmp. So these are those which are most commonly used. So you can just summarize with this single slide and elaborate when we are writing for the exam. Write a C program to reverse a string using pointers. So this is a program which is not there in lab programs, but it's sometimes asked for the university question paper. So these extra questions I have given so that you can cover or you can answer all the university questions. So here again we are making use of pointers, and also we are making use of the string length function. So here I'll explain. From in the beginning we are declaring a character array S of size 10, and we are declaring a character pointer ptr. After that we are we are declaring two integer variable and len and I, and then we are initializing the pointer variable. So the pointer variable ptr is initialized to the address of the array character array S. As we know, for a character array we need not give the ampersand before the character array variable name. So this will assign the starting address of the character array S to the pointer variable ptr. For any other variable we need to give ampersand before the variable name, but it is a character array as it is a character array, we just need to give mention only the character array variable name. Now we are asking the user to enter a string. Suppose the user entered the string as computer. So this will be taken in the variable called S. So this character array S will be having the string called computer, and so using getTest we are getting the string computer. After that we are using the string length function of the string S. So what is the string length return? It will be returning the number of characters. Here the number of characters will be 8. So the string length function will be returning 8 to len. Then if you are trying to print the length, as you can understand that the string length function which is returning the number of characters will be returning 8 to the variable len, which we had already declared as an integer variable. Now our aim is to reverse the string. You know that if you find the length of the string, we will be able to find the position of the last character, right? So the position of the last character will be 8. As you know, there are 8 characters. It will be same as the length of the character. Now what will be the index of the last character? You know that position and index is related as the position or the index number will be 1 minus the position. So here now as the length is 8, the position is also, the position of the last character will be 8 and the index number of the last character will be 7. So it is nothing but length minus 1. We have the length of the string in the variable called length. If you subtract 1 from that, we will be getting the index of the last character. You know that ptr is a pointer variable which will be having the address, the starting address of the character array. If you want to get the character of the or the character which is stored in the starting address, we need to use the dereferencing operator asterisk. So if you are using star PTR, it will be returning. In our case, it will be returning the character C. If you want to return the last character, what you have to do? We have to add that many number of characters, right? So if I am adding 1 to the current pointer and then we are dereferencing, then I will be getting the character O. If I am adding 2, then I will be getting the character M. If I am adding 3, I will be getting P. And if I am adding 4, 5, 6, 7, if I am adding 7, I will be getting the last character R. So our aim is to print the last character first, followed by the last bit character. So now if I just add PTR plus 7, I'll be able to print the last character. So the whole PTR plus 7 should be dereferenced by the dereferencing operator. So now using a for loop, we will print from the last character. So to print the last character, we have to give 7. So using a variable, instead of giving PTR plus 7, PTR plus 6, dereferencing of PTR plus 7, PTR plus 6, PTR plus 4, we will be using a variable using a for loop where I is initialized to len minus 1. What is in length? Length is 8, total number of character. We know to get the index position, we should subtract length minus 1. So it will be 7. So I is initialized with the len minus 1. That is length of the string minus 1, which is 7 in our case. So here the I variable is initialized to 7. We are checking whether I is greater than or equal to 0. We know that 7 is greater than 0. So now we move on to the line to be executed if the for loop is satisfied or if the condition is true. So here we will be printing printf %c followed by what will be printed in place of %c, dereferencing of PTR plus I. You know the I value is 7. So the PTR plus 7 will be printing the character at that address position, that is R. Now after executing this line, again it will go back to the for loop and it will decrease the I value, I minus minus, there is a decrement operator. So now the current value of 7 will be decremented to 6. Again we are printing the character at 6, which is E. So after printing R, it will be printing E. Then again we will be moving on to the for loop for decrementing I value. Again the value will be 6. It will be printing the value at the position 6. So it will be T. So it will be printing T. Then again it will decrement the I value. Again it will be printing the character at that 5, PTR plus 5. So it will be U. Then it is followed by P. So the for loop will be executed until the value is E equal to 0. So for each of these, you will be having the corresponding index number and the last index number. As you can see, the last index number will be 0. So for the character C, the last index number will be 0, right? So here the last index number, when I value is 0, it will be the condition is satisfied and it will be printing the character C. After that, when it tries to decrement the value of I, again when it try to check the value of I whether it is greater than or equal to, it is not greater than. When it reaches -1, it is not greater than nor it is equal to 0. So it will exit from there and it will go to the get stage. So now all the characters are printed in the reverse order, R, E, T, U, P, M, O, C. So this will be the program for printing the string in a reverse form. Now explain linear search algorithm to search an element in an array with a program. So you just first need to explain about the linear search algorithm. As we all know, linear search algorithm is for searching an element in an array, in a linear array or a single dimensional array. So as we know, this is most basic form of searching algorithm. In linear search algorithm, the search element is compared with each and every element in the array. But when the same searching, when we are doing using a binary search, the number of comparisons are reduced by searching the search element only with the middle element. Now in linear search algorithm, there is an advantage that the array elements need not be sorted, but for binary search it has to be sorted. Now we will see how this search algorithm works. So this is the same linear search program which we have implemented, and this is using the function called lin search. So initially we have to ask the user. So we are declaring a integer array of size 50. You can just declare the array of size 10 also. Then after that we are asking the user to enter the number of elements in the array, and we are accepting in a variable called num. You can use any variable. We had used 10, so you can use any variable. And after that we are asking the user to enter how many number of elements. If you have given 5, we have to enter 5 elements. So using a for loop, we will be getting those 5 elements, I equal to 0 to I less than n, I plus plus. So if you have entered 5, it will be entering 0 from index number 0, 1, 2, 3, 4, because we have given less than 5. So this will be accepting 5 elements. So with the index number, in the first index number 0, we'll be getting the first value. Likewise, so we have used a scanf for this for loop. If you want, you can put a curly bracket also. This is the only line which is executed for if the condition of the for loop is satisfied. For I equal to 0, at the address location, ampersand a of 0 will get a value, then a of 1, a of 2, a of 3, a of 4 will be getting a value using a scanf and the ampersand given. Now we are asking the user to enter the number to be searched. We are accepting in a variable called s. Now we are calling the linear search. So here what is the function name? Linear search. What is the arguments which we are passing? The array variable name, the number of elements in the array, and the search element. So when you are calling the function, you should be seeing that the function is declared, where we have to declare in the global area, right? Global declaration section, we are declaring and informing the compiler that it has no return type. The name of the function is linear search, and the arguments, there are 3 arguments. One is a character array, integer array, second is an integer, and third is also an integer. So you have to pass in the variable name in that same order. So A is a integer array, and then num is an integer, and s is an integer. So now when we are moving on to the array or the function definition, this is function declaration, this is function call, and here in the function definition you have to give the same order or whatever we mentioned to the compiler. Inform the compiler same, that is return type is void, the function name is linear search. The first out of the 3 arguments is a integer array, second is an integer called num, and third is an integer, another integer. So these are also known as the formal arguments. The arguments which we are passing in the function call is known as the actual argument, and the function and the arguments which we are passing in the function definition are known as the formal argument. So now, as we have studied, the value of the actual arguments will be assigned to the formal argument. So it is like a one-to-one assignment. So it should be in the same order, and it should be of the same data type. So the array along with the number, so we know that there are 5 elements in the array. Even though we declared the size as 50, we entered only 5 numbers. So we are passing only that. It's not the size of the array, but we are passing the number of elements in the array. Now inside this, we are declaring again an I variable. For I equal to 0 to I less than num, I plus plus, that is from the first character till the last character, we are going to compare the array elements. If we are compare and checking to see whether the search element is present in the array. If s is equal to a of 0, then we can just, so what is the first value of I? First value of I is 0. We are checking whether s is equal to a of 0. If it is found, element found at the position. So as you know, we are checking with the index position. We cannot return the index position. We have to return the position, that is add 1 to the index position. It will be returning 1. Now in case it is not present in the first index position, we have to increment the I value, again check. So this will be repeated until the length. So you need not give equal to less than num also is fine. Now after that, if in case you found the position at the element at the first position itself, you can give a break. Suppose if you are not able to find the element in the array, then after searching and comparing each and every element with the search element as you are not able to find, means you will come out of this for loop when this condition is not satisfied, and then we will be checking if I is greater than num. That means if the I value as either equal to num or greater than num, that is number of elements, it has exceeded the number of elements in the array, then you can print the element is not found. That means after checking each and every element in the array, but still if you are not able to find, so because we are at last also we are just incrementing the I value, and then as the condition is not satisfied, we are coming out, right? So obviously I value will be greater than num. So you will be printing element not found. Got it? So this will be the program or the linear search algorithm. You have to first explain this. They have given linear search algorithm. You have to explain and then write the program. Now, this is another program to display the Fibonacci series using recursive function. This is also we have executed. So you can. I hope you can remember that program. I'm not explaining again. And now this is explain the definition, declaration, and the initialization of the structure. So we have studied that a structure is nothing but both a derived, can be told as we can tell the structure as both a derived and a user defined data type, because we can define a structure only using the primary data type, as well as we can tell it as a user defined data type because we are creating a data type using a structure, and thereafter we can declare the variables of the structure using the struct keyword. So we are defining a data type. So structure must be first defined for their template, right? The type, that is, which is nothing but a combination of different primary data type, and then we have to declare for the structure variables. Once it is defined, then we can use that struct and the tag name in order to declare the structure variable, and also the elements or the members, right? So the structure elements or the members of each variable also has to be initialized. They are allocated memory when they are associated with the variables. The whatever we have studied in that chapter, that is we use a keyword called struct to declare the template of the structure, and it has to be terminated with a semicolon. So the whole structure definition has to start with a struct tag name and with a curly bracket, and it has to end with a curly bracket and a semicolon, while the entire statement is considered as a statement, and the entire definition is considered as a statement. Each line where each of the member variable is declared is also ended with a semicolon. Now so when each member variable is declared, it has to be declared separately with a name and the data type, and in a separate statement inside the template. The struct tag name can be used to declare the structure variable of its type later in the program. So the struct tag name which we have given while defining the template for the structure can be used along with the struct keyword in order to declare the structure variables. Okay, so you can define a structure. If it is for more marks, you can just explain about what is a structure, and then you can define how one example also you can give and then explain. Okay, so depending upon the marks, you can explain. So this declaration and definition with an example I have given. So the declaration of the structure variable. So after defining the structure, how using the struct keyword and the tag name, we can declare the structure variable I have given over here. Here structure initialization. So if you want, you can first define and then declare a structure variable and then assign the values. But if you want to have it all together, you can have, this is the structure definition. So after defining the structure, along with that we are not ending with a semicolon. Along with that we are declaring a structure variable called stud1, and then we are initializing the members of this struct of student1 with the three values, that is one first for the first member variable, and second for the second, and third for the third. So this will be the during the compile time, if you want to define, declare and initialize the structure. But in case if you want to first declare and define and declare, and then later if you want to initialize the members of the variable, you can use the scanf function, which is used in order to get the variables, or we can get the values of the members of the struct during the runtime. Now, what is static and dynamic memory allocation? So, you know that static memory allocation is what we have studied till now, that happens during the compile time, and memory cannot be increased while executing the program. Whereas in the case of dynamic memory allocation, the memory allocation of for the member variable or for the variables happens during the runtime. And if you want to increase it while executing the program also, we can do. That is, suppose we have declared an array of size 10, and if you are currently planning to enter only five numbers or elements to the array, then the remaining 5 will be wasted, right? So if you are going for the dynamic memory allocation, we are not declaring the size. We will be directly using the dynamic memory allocation, that is using the dynamic memory allocation functions like malloc and calloc, and will indicate the size of the array, and it will be returning a pointer. So this static memory allocation is used in arrays, and dynamic memory allocation is used in the in a linked list. Okay, so the static memory allocation uses more space to store variables. Difference between strcmp and strcmpi, as we have seen already, string compare can be done between the two strings using the string functions strcmp or strcmpi. So these are built-in functions in the C library, and you can access it if you are including the string.h header file. Both functions will be comparing two strings and return 0 if both are equal. The only difference between strcmpi and the strcmp is that strcmpi function is not case sensitive, that is, it is case insensitive. I stands for insensitive. On the other hand, string strcmp function is case sensitive. So string compare using strcmp will be considering the case, or the lowercase and uppercase also will be considered in order to see whether the two strings are equal. So if you are giving string 1 as small letter ABC and string 2 as, or str2 as capital letter ABC, if you do a comparison using strcmp, it will not return 0, as both the strings are not equal in terms of case. But while strcmpi will be returning 0, showing that both the capital and small letter ABC are same. Define the scope of a variable. What are the different types of scopes used in C? So the scope of a variable and also the different storage classes in C determines the same thing, that is, as we have already seen the scope of a variable and the definition, it determines the region of the program over which a particular variable is available for use. So the scope determines whether a particular variable is accessible throughout the program or only within a function, and also whether the storage class variables declared of a particular storage class will determine how long a variable is available. So we are seeing, as it has asked only for the scope of the variable, we gave definition only for the scope of the variable, and the different storage classes or the different types of scopes of the variable used in C include automatic variable, external variable, static variable, and register variable. So these scopes will determine or these storage classes will determine the different scopes of this variable. So even if it is asked for different scopes, you have to write only about these variables, and initially you have to give the scope definition of scope of variable, and then explain what is the scope of automatic variable, scope of external, static, and register. Automatic or local or auto variable. So the automatic or local variables are those which are variables which are declared within the function, and it is local only to the function block in which they are defined or declared. And then these are they can be used with the keyword auto, or any variable which is declared within the function is automatically taken as, or default it is taken as a automatic variable. Then the value which is assigned or the initial value is not initialized with 0. So any automatic variable we have to initialize, otherwise some garbage value will be assigned by the compiler. Lifetime of automatic variable is till the end of the function or the method in which the variable is defined. And so when the function is called, the variable is automatically created and it is destroyed automatically when the function execution is completed. Now, the value of the local variables which is declared within the function cannot be changed by another function in the same program. So the same variable name can be used, because of this, the same variable name can be used within different functions, as these variables are local variables are available only within a particular function. Same variable name can be used within any of the program to declare local variable. So we can you can just write an example for a local variable which is declared within main. So the same variable I is declared as a local or an automatic variable within the function called factorial also. So these two are examples of local variables declared in different functions. So the scope of the variable I which is declared within main is will be created and destroyed within that main function, while when we are moving on to the another function called factorial, it is created and destroyed within the factorial. Now, external or the global variable. The global variables that are available throughout the program. Global variables are those variables which are available throughout the program, and it is usually initialized to 0. The global variables, as we all know, will be declared in the global declaration section, and as it is outside all the functions, it will be available to all the functions which are there in the program. The value of the global variable can be changed by any of the function which is there in the program, and it is initial value will be 0, and so as you can see here, it is the I variable, which is a global variable, is declared outside the function, that is in the global declaration section. The static variable value will be persisting until the end of the program. Default value will be 0, just like our global variable, and static variable remains alive throughout the program. So a static variable will be telling the compiler to retain the value of the variable between the function call. So even if the value, even if we jump between the functions, the value of the variable which is set before jumping into the other function will be persisting even when it comes back to the same function. So again, these static variables can be either internal static or external static. That is, internal means local static variable, or global static variable. Static variable is initialized only once when the program is compiled. So you can imagine that even if we are initializing within the within each function, the default initial value, if it is 0 also, it is initialized only once, so that when we come back to the same function, the previous value will be retained. So it is not initialized every time when the program control come back to the same function. So thereafter it will be retaining the value, or it will persist the value which is been assigned in the previous call. So here I have given an example for both external static and internal static variable. Both are using the same variable name called I. Register variable, scope of this function is just like our local variable, but only thing is the place where which, or the memory area in which the area in which the variable is stored is different for the local and the register. So same thing is applicable for the register, that is it has to be initialized. It has the same, it is defined declared within the function, but only difference is the place in which the register value will be saved. So the default value again will be garbage value. Lifetime will be till the end of the function, same as a local variable. But only difference is for the faster access, the variables will be kept in the CPU register instead of memory. So local variable will be saved in memory, while the register variables will be saved in CPU. So this will help in faster access, and execution of the program also will become faster. So only problem is only few register variables we can keep. So we have to think before which variable has to be kept in register. So the most frequently ones are kept in register. Explain array of structures with example. When an array of structures is declared, each element of the array represents a structure variable. So array of structures, the concept is like instead of declaring a single structure variable, we can declare more than one structure variables using an array of structures. So here in this example, struct is a keyword and book info is the tag name for the structure, and there are three members: B name, page and price, and we are going to declare, if I want to declare a structure variable of the same type as book info, I can give struct book info book1. But if I want to have, or if I want to store the details of 100 books, I should declare 100 variables. Using an array called a book, you can declare 100 just like any other integer or character array. You can just give along with the struct and the tag name. You can define the structure variable here. Before along with the definition of the structure, we can give the declaration of the structure variable book 100 and then end with a semicolon. Individual element of the members can be accessed for each of these array variable in this way using by the indexing of can be accessed by indexing of the array variable name or the structure array variable name. Here the structure array variable name is book1, and indexing of that is index number 0. It will be starting from index number 0. Index number 1 will be the second book, and in order to assign the value of 100 as a price of this book, you can give book1 dot price equal to 100. If you want to directly assign, suppose I have a size an array of size 2. If you want to directly assign the values of the 2 books, you can give it as just like any other 2-dimensional array, a single dimensional array. We can just pass the values. So here basic is string value, so you have to enclose in double quotes and followed by the price and the number of pages. So an array of structures is just like any other array of primary data type. Here the structure is defined by the user, and then you are going to create an array of structure variables. Write notes on bit field. So bit field, as we have seen, in order to use the memory efficiently, we can specify the size of the variables or the members in terms of bits and not in bytes. So using structure and union members, you can declare the smallest or most efficiently use the declare a data type of our own and make use of the least number of bits. The variables defined with a predefined width are called the bit field. So these variables are declared with a predefined width. A bit field is a set of adjacent bits whose size can be from 1 to 16 bits in length. So a word can be made up of many number of bit fields, and the name and the size of the bit field are defined using a structure. So you can use a structure or a union in order to define the data type as well as the size of the bits. So the usual syntax is struct tag name, and in curly bracket we have to mention the data type followed by the name of the member variable followed by the bit length. So after colon we have to mention the bit length. When compared to that of the ordinary structure, here we have to mention the after colon. So we have to first mention the data type and the variable name in ordinary structure. Here after that we have to give a colon and give the size or the bit length. So when where data type is can be an integer, signed or unsigned, and the bit length is a number of bits used for the specified name. So signed bit, it will be taking 2 bits, while the unsigned, if you are mentioning, it will take only 1 bit. Field name is followed by a colon, and bit length is decided by the range of the values to be stored. The largest value which we can store is given as 2 raised to n minus 1, where n is the bit length. So if I am giving a bit length of 7, it will be like, or if I am giving a bit length of 3, 2 raised to 3, that means 8, and then minus 1, that is 2 raised to 3 is 2 into 2 into 2, that is 4 into 2 is 8, so 8 minus 1 is 7. So that will be the bit length. A number of bits, if we are giving the largest value which we can store is given as, so in our example, if 2 raised to 3 minus 1, if we are using 3 bits, we will be able to store up to the number 7. Explain in detail syntax error, logical error, and runtime error. A syntax error is an error in the source code of a program. Syntax means like if you are following a particular programming language, each language has its own syntax rules. So if you have any error, that may be a syntax error, that may be pertaining to the syntax followed by a particular programming language. If the computer program do not follow the syntax of the programming language, it will produce a syntax error. It can be misspelled variables or function names, or missing semicolon, unmatched parentheses or square brackets and curly bracket, or using a variable that has not been declared, or incorrect format in selection and the loop statement. These are all examples for the syntax error. Now we can see the runtime errors. Runtime errors are those that occurs during the execution. So you might have experienced this error after showing that 0 errors while running. It may show some runtime error, and it may crash the program while running it. So the runtime errors can occur. Runtime errors occur when a program with no syntax errors direct the computer to execute an illegal operation. So the common example is like trying to divide a variable that contains a value 0, or trying to open a file that does not exist. All these may be, so the compiler will come to know only while running the program. So these errors which are coming up during the running of the program are also known as a runtime error. Runtime errors are commonly due to wrong input from the user. So it may be because of the wrong input. That's why we are giving it as a runtime error. Runtime errors are usually more difficult to find and fix than the syntax error. Logical error. This happens when a programmer implements the algorithm, a wrong algorithm for solving a problem. You know that algorithms are written for solving a problem, but those logical errors are those which are mainly due to the wrong method of implementing a solution for solving a problem. So the algorithm itself is wrong. A statement with a logical error may produce unexpected and wrong result in the program. Common examples are multiplying when you should be dividing. So that may be the error in coding of a programmer. Adding when you should be subtracting or opening and using the data from a wrong file, displaying a wrong message. All these are coming under the logical error. Logical errors are the hardest to find and fix, and the compiler does not detect these errors. There is no indication of the error when the program is executed. The program may produce correct result for some output, while so when you are entering a proper some cases it may give a proper answer. So it will not show any error as such, but the programmer might have written the algorithms considering only a few types of numbers or input. Later on, when we try for the other similar cases, if it is not working, then it comes under the logical error. Discuss the different categories of user-defined functions and illustrate with an example. So user-defined functions, as we all know, are the functions which are defined by the programmer. So the functions which are there in the C library are the built-in functions, while those which are defined by the programmer are known as the user-defined functions. So depending upon, as we know that a function will have a function name, a function return data type, and a function and the arguments which are passed to the function. Depending upon the number of, depending upon the arguments and the arguments passed and the return value, we can categorize the functions into four. The first category is function with no arguments and no return value. Second, with the functions with the arguments and no return value. Third category is functions with arguments and one return value. And fourth categories are functions with no arguments and what there is a return value. So in the first category, function with no arguments and no return value, there is no value or there is no communication between the calling function and the called function. There is absolutely no data transfer between the two functions. So mostly the function will be called from main, and the function which is been called will be getting value from the main. So the called function does not receive any data from the calling function, and the called function does not return any value back to the calling function. Both input and output from the user and displaying of the output happens inside the function which is being called. So for this we can see in an example. Here sum is the name of the function, and we have declared the sum as with the return data type as void, and there is no arguments. From main we are calling the function called sum, and so as indicated, there is no arguments for the function called sum, and there is no return data type. So when we are defining the function also, we have to exactly mention that there is no return type as indicated by void, and an empty parenthesis will indicate there is no arguments. So here getting the values from the user and displaying the output as a result also both happens inside the sum. This will ensure there is no transfer of data between the called function and the calling function. The second category is function with arguments but no return value. This will ensure there is one-way data communication. When we are passing arguments from the calling function to the called function, there is a one-way communication, data communication. Called function receive data from the calling function, but there is no data return from the called function. In this example, the function name is sum. In the declaration itself, we have indicated that there is no return data type. That means there is no return value, but the arguments are two integers. So here we are calling the function called sum, and we are passing the two variables, integer variables, and in the function definition we can see that the sum will be the function is indicated by no return data type, which is void, and there are two values which are passed as arguments, integer a and b. So the result is again assigned the values of the sum of the two arguments which we are passing, and the output is displayed within the function. This will make sure that the value is not returned back to the main. So there is only one-way communication, passing of arguments from the called function to the calling function to the called function, but there is no return from the called function towards the calling function. And now the third category is with the arguments and with the with arguments and with return values. So there is both sides, where the function being called is getting a value from the as arguments, and the function being called is returning a value to the called function. So there is a two-way communication between the called function and the calling function. Here in this example, sum is a function, and it is indicated by an integer return data type and two integer values as the arguments. So here, after finding the sum of two values, we are assigning to a variable called result. So the function, when it is called from the main, it is passed with two arguments, and we are expecting a return value which is been assigned to an integer data type variable. So here again, the input and output is happening within the main itself. After getting input, we are calling the function, and then within the function we are calculating the result, and we are returning back to the main. So displaying of the output also happens within the main. So this will make sure there is two-way communication between the called function and the calling function. Function with no arguments but return a value. This is a fourth type in which there is again one-way communication, but the calling function is not sending any arguments, but the called function is returning a value or a data type, returning a value of a particular data type back to the main. So here again there is one-way communication, but this time it is communication between, or the value return value is sent by the called function back into the calling function back to the called function. So here again the example is sum. Here the empty parenthesis indicated there are no arguments, but the return data type is indicated as int. So sum will be returning a data type of integer or variable of data type integer. So that variable is declared. Result is a variable which is of integer data type, but we are not passing any arguments to the variable called or the function called sum. So this will be an example for a function with no arguments but with a return value. Now, give the difference between an asterisk and an ampersand. So the asterisk or unary operator is designated as a variable to make a variable as a pointer. So you can, if you are using it in the declaration part along with the data type and a variable name, between the data type and the variable name, it will be designating a variable as a pointer, while the ampersand operator is used to assign the address of the variable to a pointer. Again, the asterisk or the indirection operator, which is also known as a dereferencing operator, is when it is used along with the pointer variable, is used to access the value of the data which is stored at that particular address indicated by the pointer. So n equal to star ptr will be assigning the value which is being stored in the pointer variable, not the address. It is the value which is being stored at the pointer variable. It is been assigned to the variable called n. So there are the asterisk has two meaning. When it is given between the data type and the pointer variable, it indicates it is designating a variable as a pointer variable, and it is taken as a unary operator. While when the asterisk is given along with a pointer variable, then it will be getting or accessing the value which is being stored at that particular address indicated by the pointer, while ampersand is used to get or to assign the address of a variable to a pointer variable. Difference between the call by value and call by reference. In call by value, a copy of the actual argument is passed to the formal argument of the called function, while in call by reference, the location or the address of the actual argument is passed to the formal arguments. Now, any change made to the formal argument in the called function has no effect on the values of the actual argument, because here we are passing only the dummy copy. But when we are going for the call by reference, by access the addresses, the value of the actual argument can be altered. So there is only one copy, and in that itself directly we are changing the values. In call by value, actual arguments cannot be modified from the called function, as we are passing only the duplicate copy. But in call by reference, actual arguments can be modified from the from the called function. The formal parameters are ordinary variables, while the formal parameters are the pointer variable. So as we are passing address in call by reference, we have to get the formal parameters in the function definition as a pointer variable. As we know that addresses can be assigned only to a pointer variable. In call by reference, the address which has been passed will be directly assigned as a one-to-one assignment will happen. So we have to indicate it as a pointer variable. Separate memory location for the formal and the actual parameters. We can see that in call by value, as we are passing a duplicate copy of the actual values as the parameters or actual parameters. These are given different storage locations, but in call by reference, there is only one memory location for both the actual and the formal parameters, as we are passing the address of the actual parameters. Explain call by value and call by reference with an example, or what are the difference of calling a function with the example. So and the other slide was indicating the difference between call by value and call by reference, but here they are asking for, so we can write in the form of a table, but here explain call by value and call by reference with the example. So both you can the same thing what we have written over there, instead of writing it as a difference between or the same point, how it differ for both, we can just show write as like explain it like this two ways. That the arguments can be passed to the function, that is one by call by value and the other is called by reference. In call by reference, the process of calling function using pointers to pass the address of the actual argument of the variable is known as the call by reference or call by address. These are other names, and the other one is passed by pointers. It provides a mechanism by which the function can change the stored value in the calling function. So when we are passing the address, actual stored value is getting changed. A dereferenced variable is used in the formal parameters to pass the reference to the formal arguments which are there in the called function. Now in passing values to the function, when we are going for call by value, we are actually passing values to the function. And in call by value, a copy of the actual argument is passed to the respective formal arguments. Any change which is made to the formal argument will be affecting the values of the actual argument. In call by value, actual arguments cannot be modified from the called function. So because of the duplicate copy, whatever changes we make will not be affecting the actual copy. So there is a, here I have given an example between call by value and call by reference. In call by reference, as we can see, we are passing the address. Here this difference you have to remember. Here we are passing what is the name of the function, exchange, right? So the function we are passing the arguments as ampersand x and ampersand y. Here again the name of the function is x, but we are passing only the variable name x comma y. So this example also, depending upon the mark, you can write. What is a pointer and how is pointer initialized? Pointers are the variables, as we know, that holds the address of another variable of the same data type. And the pointers are derived data type. You know, it is derived from the existing primary data type, and it is built using the primary or the fundamental data types. Pointers pointers contain memory address as their values. So in pointers we will be storing the address. Process of assigning the address of a variable to a pointer variable is known as the initialization. So here first we declare a variable, assign a value, and then we are declaring a pointer variable. So this integer a is an integer data type, and it is variable, and it is assigned a value called 10. Now in this step we are initializing the pointer variable with the address of the integer value. So assignment operators used to initialize the pointer variable, and ampersand returns the address of the variable associated with it. A pointer variable can also be initialized to see null or zero. We can either initialize it to the address of another variable, or we can initialize to a null or zero. No other constants can be assigned to a pointer variable. In what ways an array is different from an ordinary variable? Explain the characteristic of an array. So array holds the multiple values, whereas an ordinary variable holds a single value. So when we declare an array of size 5, we will be able to store 5 values, while when we declare an ordinary variable, we will be able to store only a single value. Arrays are derived data types, whereas variables like integer, float, character are the primary data type. We know that arrays are derived from the primary data type, and array enable us to use a single name to represent a collection of items, while a variable name represents a single item. Now, characteristic of an array holds elements which have the same data type. Array elements are stored in subsequent memory locations, and array names represent the address of the starting address of the array elements. Two-dimensional array elements are stored row by row in the subsequent memory locations. How does a structure differ from an array? Arrays are derived data type, while structures are also can be considered both as a derived and a user-defined data type, but more it is told as a user-defined data type. An array is a fixed size and sequenced collection of elements of the same data type, while structures are constructed data types for packing data of different data type. Here arrays will have same data type, while structures will have different data type. An array can be used to represent a list of numbers or a list of names. And if you declare an integer data type, then it will be an integer, a list of numbers we can store, or we can, if you are declaring it as a character array, or if it is a two-dimensional character array, we will be able to store a list of names. Structures are used to organize complex data of different data type. But there in arrays it is all of the same data type. Array enable us to use a single name to represent a collection of items, while structures are used to organize a complex data of different data types. So here I have given an example for an integer array of size 5, and here we are accessing to the integer or the third value. The first index number will be having the first value, second index number will be second value, and third will be having the third item which is placed in the array. So now for a structure we can have, so here in arrays we have the same data type, but in structure we have different data type. A title which is character, author also character, subject is character, while integer ID is an integer data type, book 1, book 2 and book 3 are the structure variables. Explain the arithmetic operators that are permitted to pointers. Pointers, as we all know, will be having the address of another variable. So the arithmetic operations which are possible for the addresses of another variable are only addition and subtraction. It cannot be used for division and multiplication. So there is no meaning in doing multiplication and division of an address of a particular variable, but when we are performing an addition and subtraction, the value with which it is getting incremented or decremented will be the factor called the scale factor, which is the length of a data type. So the scale factor determines by how much value it will be incremented or decremented during addition and subtraction. It can also be used for both the post and pre-increment, and also the shorthand operation of both the addition and subtraction can be applied on pointer values. So as we know, the scale factor of integer, as for integer now it will be 2 bytes, as but for a character it will be 1 byte. So when we are incrementing a pointer variable by 1, it will be incremented by, so if it is an integer variable, it will be incremented by the scale factor of 2 bytes. If it is a character variable, then it will be incremented by a scale factor of 1 byte. So if you are decrementing also, so if you are in if it is a float point variable, then if you are incrementing by 1, it will be incremented by a scale factor of 4 bytes. Pointers can also be used for comparison. So between two pointers we can use relational operators of like comparison operators, whether it is equal, but the pointer comparison is possible only if two pointers are pointing to the same array, that is, or the same data type. It can be either two pointers pointing to the same array or two pointers of the same data type. So suppose in this example there is an integer array called I, and there are two integer pointers ptr1 and ptr2. ptr1 is given the address, starting address of the integer array I, and then ptr2 is assigned a address which is incremented by 3. That means as a scale factor of integer is 2 byte, it will be incremented by 6 bytes. Then the address of ptr2 will be an address which is incremented by 6. So ptr1, suppose it is 2800, as I have given in the example. If ptr1 is 2800, if you are incrementing ptr2 by 3, that means as it is an integer, it will be incremented by 3 into 2 bytes, that is by 6 bytes. Then it will be incremented to the address 2806. Now if you want to compare between the two pointers, as we know that these two pointers are of the same data type, we can and it will be pointing to the same array called I, we can compare these two pointers ptr1 and ptr2. So we can see that if ptr2 is equal to ptr1, it will not show an error, as it is both pointers are pointing to the same array of the same data type. How can a structure be defined inside another structure? So a structure defined inside another structure is also known as a nested structure. So that is also known as nesting of structures. So in nesting of structures, in this example, the outer structure is called a salary. The tag name of the outer structure is called salary, and it is having the member variables called a name, department, and the third member variable is allowance. So the third member variable allowance is itself a structure without any tag name. But so this is a difference between an outer structure and an inner structure. Inner structure will not be having any tag name. It is just introduced by the or defined using a struct keyword and followed by the struct variable. So we will be declaring a struct variable along with the definition of the struct. What are the members of the inner structure? Dearness, house rent, and city. The outer structure, the variable name is employee. The salary structure contains a member named allowance, which itself is a structure with the 3 members. The inner structure members are defined with no tag name and can be referred with a 2-member operator. So the first outer structure variable followed by a dot, and then the inner structure variable followed by a dot, and then you have to write the member variable, and it is assigned with a 1000. So we are allocating, or we are assigning 1000 to dearness for the employee, for the allowance of the employee. What is recursion? Write a program to find the factorial of a number using recursion. As we have studied, recursion is nothing but a function defined in terms of itself. So this function is incomplete if you are not calling the function. So that means a function contains a call to itself. So recursion must have at least one terminating addition. Otherwise it will be repeatedly calling and it will result in an infinite loop. So you can write the example for recursion. Example like a GCD program or factorial program. So here this example it can be asked separately, or you can write as an example for the recursive program. Write a C program to find the factorial of a number using recursion. So here you know what is factorial of a number. Suppose I identify factorial of 5 will be 5 into 4 into 3 into 2 into 1. So in order to find the factorial, we are making a recursive call of the function called factorial. So the factorial is a function which is defined in terms of itself. That means this is the definition of the factorial function. In this definition, which is written within this curly bracket, we are using the, or we are calling the factorial again. Understood? So when we define a function with the same function, so in order to define factorial, we are using factorial again. That type of functions are known as recursive function. So here initially we will ask the user to enter positive integer or any integer, that's it. So the number can be accepted in any variable. You can here I have used the variable called num. Then as we have declared the factorial or the function as having a return data type of long int and an argument with a variable called integer variable n, you can integer variable, you can call the function the factorial with a variable which is given, which is an integer variable. The value, the variable name, if you are not mentioning here also no problem. And if you even if you give another variable name, suppose a, and here if I am giving b, no problem. Here I have given num and here I have given n. That does not create any error. Here just we are informing the compiler that we are passing an integer variable as an argument. Here we need to pass an integer argument, that's it. It will not be seeing the name of the argument. Again, in the function definition also we can use any variable name. The only thing is it will be assigning the value of the actual argument to the formal argument in the one-to-one order. So it has, and it should be of the same data type. Here we can see that factorial is a function which is having only one argument, and it is called, and it will be returning a long int data type. So fact is a variable which will be declared as a long int. Here you can see it is declared as a long int, and it will be able to accommodate, or it will be able to assign the value returned by the factorial. So when we call this factorial, it will reach this line, it will jump to this line, and it will execute line by line. If number is not equal to 0, suppose I ended 5, number is not equal to 0, then what we have to do? Return number into, what is number? Number is 5, right? So we will be finding 5 into factorial of num minus 1, that is num minus 1 is 5 minus 1 is 4. Again we are calling factorial of 4. So again the call comes over. It will not go to the else part only. When it reaches the factorial, again it will go back to the function definition. Again the value of 4 is assigned now to the variable called num. If num is not equal to 0, now the current value of num is 4. 4 is not equal to 0, so it will come to this line, return, instead of 5, now it is becoming 4. 4 into factorial of 4 minus 1 is 3. So again we are calling factorial of 3. It will come over here. Again it will check num is not equal. Now the current value of num is 3. 3 is not equal to 0. Return 3 into factorial of 3 minus 1 is 2. Again it will call factorial of 2. Current value of num will come 2. It will come and check if num is not equal to 2 is not equal to 0. It will return 2 into factorial of num minus 1, that is 1. Now it again will call factorial of 1. It will come over here. It will check 1 is not equal to 0. It will return 1 into factorial of 1 minus 1, that is 0. So when it is again going factorial of 0, it will call factorial of 0. So if num is not equal to 0, but our current value of num is 0, so what will happen? It will go to the else part. Return if as it is as it is equal to 0, it will come to the else part, and it will return 1. So what will happen now? It will be the value of 1 will be substituted in the previous call of factorial. So this is what happens when we call a recursive call. So now the function, when it is called, we as I told, recursive call has a problem that it will be backtracking the whole way what it has come now. So now the value of 0 will be substituted in the previous call, and then it will find the value, that is 2 into so the factorial of 0 will be returning 1 now, so that 1 will be returned to the previous call, and then it will substitute and find the value of 1 into 2, and then the value will be substituted in the previous call, and then it will be finding 2 into 3, and then again 2 into 3 is 6, right? 6 will be substituted in the previous call. 6 into 4 is 24, and 24 will be substituted in the previous call. 24 into 5, right? 120. So this will be the final answer. After backtracking, it will be returned back to the main function. So the calling of the recursive calls and the returning of the values happens as a backtracking, and then the final call will be returning back to the main function to give the final value, which is the factorial of the particular number. So here in this will be 120. So it will be printing the value of the factorial of the number. So instead of number, here the value will be printed as 5, and the fact value, which is 120, it will be printed over here. So this becomes an example for the factorial recursive function. Now, write a C program to generate a range of prime numbers using function. So we have written a program which will be asking for the same thing only. If you are entering. No, we have written a program for finding whether a number is prime or not. But we have written a program for finding the Fibonacci series of a particular length. But now here this program, which is asked in one university question paper, is to generate a range of prime numbers. You know which are the prime numbers, but it is not a program for checking a number whether after entering a number whether it is prime or not. Here it is for printing a range of prime numbers. Got it? Just like our Fibonacci series, if you are giving a length of 7, it should be printing all numbers from 1 to 7 numbers which are prime. Okay, so here we will be asking just like the other Fibonacci, here also we will ask the ender to enter the limit of the length of the number of prime numbers to be printed. So we are getting in a variable called limit, or you can get it in a variable called n, no problem. While number, so we know that 1 is neither prime nor composite, so we are checking only from number 2. Okay, so we are initializing the variable called num2 2, and we are setting the flag variable as 1. So now, as you are all familiar, like I had initially avoided using the flag variable. Flag is a variable which we can set initially to 0 or 1, and then if something particularly happens, we can set initially if you have set it to 1, we can set to 0, or if you have set it to 0, you can set it as 1. So in this program, initially we are making flag variable as 1. If something happens, then we are making it as 0. Got it? So in order to trap, or in order to check whether something is happening, we are making just like if train pass, we are making in order to indicate that something has happened or the train has already passed, the station master will be showing a particular flag like that. No, here we are checking whether some event has happened. If something happened, then with the flag variable we can check whether it has happened. So initially if you are setting it to 1, then if our aim is to find whether a particular number is divisible by any other number other than 1 and itself, right? So we are going to divide a particular number which is starting from 2. From 2 onwards, each number will be dividing and seeing with all numbers ranging from. So again, we are not dividing by 1 and itself. In order to avoid that, we can start the I variable from 2. And one more thing is, we need not divide all the. So if I take a particular number, it will be completely divisible only by exactly half the number. Suppose if I take 6, only the numbers which are like, I'll be able to divide completely or divisibility can be checked only by the exactly by half of that number, right? If I take 3, 6 by 3 will be giving me 2, right? But there is no point in checking whether 6 is divisible by 4, right? The least possible divisible number or the number of times a number will be divisible is 2 times, right? So we can limit the checking of the numbers of divisibility between 2 and number by 2. That means if you are checking whether 6 is divisible, you can check you can check 6 by 2, then 6 by 3. That's enough. If you are taking another number to check whether a number 15, whether it is prime, we need not check whether 15 is divisible by 1, right? Because we know 15 is always, any number is divisible by 1 and itself. So we are starting from I equal to 2. So the first value of I will be 2. So you know that I is 15 by 2 is not divisible. Then we will take 3. Then you know that it is divisible, it is 5 times. Then if you take 4, then you know that it is not divisible. Then again if you are taking 5, you know that it is completely divisible. Then if you take 6, 6 if you take, you know that it is not divisible. Then if you take 7, you will be you will see that it is again not divisible. So what is 15 by 2? 15 by 2 will be like 16 by 2 will be 8. So 15 by 2 will be something between 7 and 8, right? So you will be 7 and 8. So you will not be you know that it will not be dividing if you further find a number which is greater than 7, right? The least possible number which can divide and give a result, or 2 times if it goes only, then that will be the least number which can divide, right? So if you, there is no point in checking any number which is above the number by 2. So we will stop the number of iterations or the value of 4 up to num by 2. So this will limit the number of for loop iterations. So you have to start from I equal to 2 and I less than num by 2, and each time the value of I will be increased. So if you are finding in the next line, for I value, each of the I value, we will be finding the mode with the I. So the current number, if it is divisible by I, then it will be giving him with the mode, the remainder will be 0. If you find any number is divisible, then we are setting the flag to 0. Understood? So after this, when it comes out of this for loop, for all the numbers, each number I am taking and checking whether the number is divisible by any number other than itself and other than 1 and itself. And also we are checking only up to the half of the like if 15 is the number, or if it is 16, then we will be checking only up to 8, right? Num by 2, that is 16 by 2 is 8. So with this, if I am finding any number which is divisible, then I am setting the flag to 0. Now after coming out of this for loop, for each variable, we will be checking if flag is equal to 1. If flag is still equal to 1, that means it was not divisible by any number. Then we are printing that number as a prime number. Then after that we are incrementing the number. So in this way, if you are performing, we will be able to find all the prime numbers between 2 and suppose if you enter the length as 7, you will be able to print the 7 prime numbers starting from 1, starting from 2. Okay, so 7 prime numbers. So you know that 1 is neither prime nor composite. Again, when we check 2 is again, you know that 2, even though we may feel like it is divisible, and only you know that it is divisible by 1 and only by itself, right? We don't have any number between 1 and 2, so again 2 is also prime. Then we will take 3. Each time when we increment num, we are taking the next number. Then if you find, you will be finding that 3 is divisible by 1, 3 is not divisible by 2, not divisible, and again 3 is divisible by 3. So again 2 is prime, 3 is prime. Again we will increment num. Then we will get 4. So 4 is divisible by 1, 4 is divisible by 2, and 4 is divisible by not divisible by 3, and again 4 is divisible by 4. So when we find a number which is divisible by 2, for 4 flag will be set to 0. So that means flag 4 is not a prime number, so it will not be printed. Now as we have given the limit as 7, again we will increment num to 5. 5 is divisible by 1, and 5 is not divisible by 2, 3, 4, and 5 is divisible by 5. So again 5 is, so it will be on the display, we will be printing 2 will be there, then 3, and after that 5. Then again we will increment, and the value of num will be 6. 6 is divisible by 1, 6 is divisible by 2, 3, 5 is 4 and 5 is not divisible, and 6 is divisible by itself. So again 6 is not prime, we will increment the value of num to 7. 7 is divisible by 1 and 7 is divisible by itself. So again we will be printing 7 as prime. So we got only 4 numbers till now, so we will take 8. We know 8 is not prime, 9 is not prime, then 10 is not prime, then we will take 11. 11 we know it is a prime number, so it will be printing 11. So as we gave the length as 7, here up to 5 numbers only we got. After 11 num will be increased to each time, no, num will be increased to 12. So 12 is again it's not prime. 13 is divisible by 1 and it by itself, so it will be printing 13. And then 14 is divisible by 1 and then 2 and then 7, so it is not prime. Then again 15, when we check, it is divisible by 1, 3, 5, etc. And then when we take 16 also it is divisible, so we will take 17. 17 is divisible only by 1 and by itself. So we got the 7 numbers which are prime. So this is a program which will be printing 7 numbers which are prime. The other program was for checking whether a number is prime or not. So this is the difference, so you can execute and see, because I am not giving extra program, it is all programs which are given in the question paper.